Now let's see the next instruction, increment and skip with 0. Okay, what about the last one? I think last one has taken 5, right? So how many has it taken? How many clocks? I didn't count it actually. So it has taken from T4 T5, I think it has taken 6 clocks it has taken, right? And the next one is increment and skip with 0. So this particular instruction is helpful in implementing the loops like for loop, while loop, all those. So the meaning of this one is, we are going to have in the memory somewhere, we are going to have a variable, let's call it I. Now we have to get this I and then increment its value, right? And if this value happens to be 0, then we are going to skip the next instruction and we go to the instruction below that. In case if this value is non-zero, then we will not skip, we will execute the next instruction. Therefore, executing the next instruction, which means executing the instruction, let us say you are at instruction 100, then what I do is, I'll decide whether to execute 101 or 102 depending on what the value of I is. In case if the value of I now is -1, then I'll get -1, increment it to 0, and since it has become 0, I'm going to skip 101 and I'll directly go to 102, right? In case if I is, let us say 10, then I'll increment it and it will become 11, so I will not skip the next instruction, I'll just execute 101. Therefore, whether to execute 101 or not will depend on what the value of I is. If I happens to be -1, it will not be executed. If I happens to be any other number, it will be executed. Got it? So now how to increment this, how to skip an instruction. So when I'm executing the instruction 100, program counter is already incremented once, which means program counter will contain 101. So if you have to skip one instruction, you need not increment it 2 times. Already it has been incremented once, therefore you increment one more time. So incrementing program counter one more time in the execution loop is enough to skip the next instruction. You need not see from 101, if you have to go to 102, you might think that I have to increment program counter by 2, but then while fetching the instruction 100, already program counter is incremented by 1. You need not again increment it by 1. Got it? So now let's see what should be done exactly. So first thing is, we cannot increment an operand which is present in the memory. Our computer, whichever we are designing, does not have this support that we can directly operate with the operands in the memory. So we have to load it into the registers and there we need to work on it. Got it? So now let's see IZA. So how can we know that we are executing? If we are in T4, right? And what is the instruction? D6. It means that I am trying to execute the instruction ISZ, and already effective address is present in address register, right? So first I have to load from memory the operand. The operand address is computed already in T3. Either directly it is given or indirectly, whatever it is, we computed it. Now we have to load it to DR. So how do you think that this one will be done? Already address present in AR is given to the memory by address bus, right? Now that common bus or the data bus has to select that particular memory by giving 111 in the select lines. So this particular word will come on to the bus as early as possible. That depends on the memory cycle time, right? So which means if this is the cycle, this is the cycle if you are using, and this is the T4, then I am saying that initial part of it itself, and this depends on how fast your memory cycle is, how fast we can read a word from memory. Depending on that, by this time, assuming that this is the time required for the memory to react or to read from memory, by this time the required word is present on the bus, right? And whenever it is present on the bus, it is automatically present at the input of all the registers. Therefore, we'll simultaneously enable the load input for DR. So at this point, at this point DR will be loaded. Got it? So wherever, even though you are giving the load signal from initially here, if this is the load signal, even though you are giving it in along with this T4, actual transfer will happen at this point because it is positive edge triggered. Every register is positive edge triggered. Therefore, by the end of this particular clock, or this particular T4, then only DR is incremented. Sorry, the data is loaded into DR. So now incrementing DR cannot happen in the same cycle. That is why I am putting in the next cycle. Got it? So in the next cycle, for this instruction D6, I am going to increment it. DR is going to be incremented. Now you might think that why can't we put this instruction here, this instruction perform it here? The reason is simple. The data in DR will be available only at the end of the clock, and if you try to increment it simultaneously, then what happens is, at this particular instance of time, at this point in time, both the operations will try to happen, isn't it? So this is DR, data register, one is load and the other one is increment. Now if you try to enable both of them simultaneously in the same signal, what happens is both of them will try to happen at the same time, and the result of it will become unpredictable. That is why let's do it one after the other. In case if the loading would have happened in the first half, like this, first half of the cycle, let us say this loading is positive edge triggered and increment is negative edge triggered, then I could have used the same cycle to perform both the operations. But since both are positive edge triggered, which means both operations are going to happen only at this point, I have to perform one, then the next. Understood this? So when will this one happen? DR equal to DR plus 1. Again, if in the next clock, right? So in the next clock, this operation will happen here, right? Which means your particular T5 will be active here, right? T5 will be active here. At the end of it only it will happen. Therefore, at the end of this one, it is going to happen, right? Now we have to test it. So in order to test it, in order to test the value of DR, can I test it in the same cycle? I cannot test it because cycle is over already. So I need to go to the next cycle. Let us say the next cycle is T6. Now at this cycle I have to test it. So test it and load it also, right? So the DR value, whatever is present, it has to be even stored in the memory because the particular value has to be incremented. So let me store it back. So whatever is present in DR, it has to be sent into memory, and the address is already present in the address register. So when will this operation happen? So this operation will happen in the first half, or whenever our memory is ready, right? So depending on the speed of the memory, this operation will be as fast as possible. See, while sending the contents of the register onto the bus, you can do it anytime. You need not wait for the positive edge triggered, because all the registers are nothing but collection of flip-flops, and all of them are already connected to the multiplexers. So whatever is present in the multiplexer in the registers, they are ready to be available on the bus, so you need not wait for them at all. So this particular operation will take a very less time, or at least it will not need to wait till the end of the clock. Got it? So anyway, this is going to happen parallelly, and along with this I'll test if DR equal to 0. How can I test if DR equal to 0? So testing if DR equal to 0 can be done by a AND gate or OR gate. I'll connect all the elements of DR to a OR gate. If OR gate output is 0, it is a multiple input, many input OR gate. If it is 0, then I can declare that the value is 0, isn't it? If DR equal to 0, then what I try to do is I'll increment the program counter plus 1. So when will this will happen? This will happen at the end of the clock. Anyway, we are not going to use the bus here. So bus is used in order to place dr, and so I can do these two parallelly, right, because we are not going to use any bus. So incrementing PC by 1 is enough to skip the next one, isn't it? Why? Because already PC is 101, and now if I want to make it 102, I have to increment it just by 1. Got it? So how can I do PC equal to PC plus 1? It is nothing but giving the increment signal to the PC register. Okay, so by this everything is over, right? So the instruction is complete. What did we do here? We have we have loaded it into a register, the data into data register from the memory, incremented it, stored it back, tested it, and if it is true, incremented it, otherwise we leave it as it is. So by the end of T6, everything is done. So next instruction has to be fetched. Next instruction will either be 101 or 102 depending on whether this instruction has, this control signal has been given to increment PC or not. So anyway, since we have to start the next fetch, we have to do SC equal to 0. Got it? Now how many clocks happen here? T0 to T6, which means 7 clocks here. So the memory instructions or the memory related instructions are taking different times. Some are taking 5 clocks, 6 and 7. So we need not worry about it, because at the end of every instruction we are again setting SC to 0. So we need not think that we have to run every instruction for 7 clocks. No need. If an instruction is going to be over by 5 clocks, it is okay, because at the end of that instruction we are again making SC to 0, which means T0 will start and the next instruction will start like this. If an instruction takes 5 clocks, immediately the next instruction will start here. You need not wait for 7 clocks and start the next one. Got it? So that is how all the memory related instructions are implemented. Now let's see the register related instructions and then the IO related instructions. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494555454. Okay, thank you.